AP Cram, Calculus AB, Free Response, Exam Review. Question 5, the sum of boundary curves between intersection points. Let f and g be the functions defined by f of x is equivalent to 1 plus x plus e raised to the x squared minus 2x. So this curve right here represents f of x. And g of x is equivalent to x to the fourth minus 6.5x squared plus 6x plus 2. This curve right here represents g of x. Let R and S be the two regions enclosed by the graph of f and g shown in the figure. Find the sum of the areas of the regions R and S. Okay, so what you're tasked with is finding the sum of this enclosed region and also the sum of this enclosed region. So let's just take a quick stock of this problem, all right? So while I'm yapping and talking, think of your strategy, but maybe I might say something to help you. So you're given the graph of boundary curves of two planar regions. The first planar region is planar region R, and the second is planar region S. And they're both situated in the first quadrant of a Cartesian coordinate plane, okay? So we're already told that the boundaries are fixed by f of x and g of x, okay? And so now we're asked to find the sum, to sum the areas of these two regions, okay? All right, so think about your strategy for a moment, and then let's get into the proper solution. All right, so the first thing that you have to notice is that the graphs of f of x, that's this graph, and y equals g of x, that's this curve right here, intersect first at the points 0, 2, this mystery point right here, and 2, 4. All the intersection takes place in quadrant 1. Although this is on the y-axis, you can still kind of, consider it quadrant 1, okay? And the third point of intersection that I previously mentioned was the mystery point, is a point that we'll call A, B, A representing the x-coordinate, B representing the y-coordinate. That point of intersection occurs at 1.032832 and 2.401108, okay? All right, so we're kind of set up now to find the sum of the areas of regions R and S. So the first area that we're going to analyze is the area for region R. Again, we have our points of intersection, and the way I like to analyze areas is in terms of d of x. dx, that's the change in the x-axis as opposed to dy, the change in the y-axis. Some of you are probably more comfortable doing the y-axis. I'm not a math whiz in that sense, so you can go ahead and do that, but you would still arrive at the same answer, okay? But the one thing that you have to notice, and this is the thing I like about calculus, it's mathematics, but it's also common sense and intuition. It's a thinking man's game. If you're going to analyze this area between the 0 and point A, which is 1.03 ... you need to recognize that the function g of x is on the top of the function f of x for this particular limit, okay? So for this particular expanse, we're going to do the integral from 0, because the x-coordinate here is 0, to a, and the a-coordinate is 1.03283, okay, of g of x, that's this function, minus f of x. What the function on the bottom is subtracted, okay? And this is basically how you find the area of a region that's, enclosed by points of intersection. You just do a basic integral, set up your boundaries, and make sure you orient the functions properly, okay? So if you go ahead and plug this into your calculator, please learn how to do this on your calculator. If you don't know how to plug in this integral, then I'll show you in another video snippet, okay? When you plug this in and you set your limits, and don't put a when you input it into your calculator, set your limit at this point, okay? And you're analyzing basically a definite integral, you're going to get 0.997427, okay? So this is your first region. Then you can go ahead and do a second integral. Some of you already know how to do this all in one shot. That's okay. But, for those of you who don't, like myself, you can go ahead and analyze the second integral. And we're analyzing the area S from point A, again, which is 1.03 ... to point 2. So these are our bounds of integration on the x-axis, okay? All right, so again, you're going, in your calculator, you're going to input a, which is 1.03, and then you're going to input the limit 2. But notice in this region, function f is atop function g. So in orienting your integrand, when I say integrand, I mean the equation of integration, you're going to first input f of x minus g of x, okay? And don't forget, don't actually write this out verbatim. This is f of x, and this is g of x, and this is what you're putting into your calculator. Same here, you put this function in first, minus, if you want, you can enclose this function in parentheses so that everything is subtracted properly, this function, which is f of x, okay? And when you analyze this integral between 1.03 ... and 2 along your x-axis, you're going to get 1.006919. And if you add those two together, you get an answer of 2.004 units squared. Okay? So this is the area, the sum of the areas for R and S.